Hey guys, Mr. Bohoric here, and today we're dividing with exponents. So, on the other lesson, if you haven't watched it yet, you probably might want to do that, multiplying with exponents, because I'm going to be using some of the same rules every once in a while. So, you definitely want to watch that one before you watch this one. But with dividing with exponents, let's say I have 6 to the 5th divided by 6 to the 3rd. Okay, well, let's write this out long ways. Let's see what it looks like. Okay, so 6 times 6 times 6 times 6 times 6. Okay, 5 times. And 6 times 6 times 6 on the bottom. Now, just like with any kind of fraction or division problem, when you have the same thing divided by the same thing, they cancel out. So, for example, like 7 divided by 7, this cancels out to a 1. So we can do that here. A 6 over a 6 cancels out to a 1. 6 over 6. 6 over 6. And I'm left with 2 6's on the top and a 1 on the bottom. It's just like nothing here. It's a 1. So 6 squared on top and a 1. So that's just 6 squared. So if you look at the exponents, you can probably figure out what the rule is. So when you're dividing with exponents, let's see, 5, 3, and you get 2. Oh my gosh, 5 minus 3 is 2. So you subtract the exponents. So that's the rule for dividing with exponents, is you subtract exponents. To take a look at this again, let's say we have x to the 25th divided by x to the 18th. Well, 25 minus 18, that's 7. So x to the 7th is what our answer would be. We just subtract the exponents. So that's all nice and good, but let's add a little bit more onto it. Okay, just a little bit. So example 2. Let's say we have 5 to the 4th, x to the 6th, and 5 x on the bottom. Okay, so we've got two different bases here. We have x's and 5's. So this rule only works. We can only subtract the exponents for powers with the same base. So we've got a 5 to the 4th on top and a 5 to the, remember that's to the 1st on the bottom. So 4 minus 1 is 3. So we're going to have 5 to the 3rd. Over here we got x to the 6th divided by x to the, remember that's a 1, first. So 6 minus 1 is 5. So 5 to the 3rd, x to the 5th. And if we want to simplify that further, it's 125 x to the 5th. And that's our answer. Okay, so this is all nice and everything, and it's really not that bad. But what if I have 3 to the 4th over 3 to the 4th? Okay, so a little bit of a curveball, but not too bad. Well, I got the same base, so I subtract the exponents, and 4 minus 4, that's 0. 3 to the 0, but wait a second. Huh? Well, the cool thing about 0 as an exponent is that it works out to be really nice. Anything raised to the 0 power is 1. That's it. Because look at what you got over here. You've got 3 to the 4th, which is just a big number, okay, divided by the exact same big number. Just like I said earlier, 7 over 7 is 1, so a big number over the same big number, that's also 1. And that's why the 0 power, because when you subtract the exponents you get 0, it's always going to be 1, because that means that you have the same thing over the same thing, and that is always 1. Alright, so that's cool and all, but let's do something a little bit different. Let's say I have something like x squared over x to the 4th. Now wait a second. If I use my division rule, okay, I'm supposed to subtract the exponents. Keep the base and subtract the exponents. That's x to the negative 2nd power. But wait a second, I'm just feeling funny about this problem. What if I did it a different way? What if I wrote it out the long way? Like I did in the beginning. So that's x times x divided by x times x times x times x. Well, just like before, there's some stuff that cancels out. So these x's cancel out, these x's cancel out. And I'm left with 2 x's on the bottom and nothing on top, a 1 on the top. So that's 1 over x squared. Now, wait a second. This is the exact same problem. This is the same as this, but I got two different answers. Well, the key here is that x to the negative second and 1 over x squared, they're the exact same thing. So, they're the exact same thing. What we want to write, though, is 1 over x squared. With a negative exponent, we don't really consider that to be simplified. So if we end up with a negative exponent, we want to convert it. Probably shouldn't use black ink. There we go. We want to convert it to a fraction like that. So let's do some examples doing that. We're going to have to erase a lot. All right. There we go. All right, so I don't even remember what example I'm on. How about 5? That sounds good to me. So, example 5. Let's say I have, and we'll start out simple. A to the 4th over a to the 12th. Okay, so I subtract the exponents, same base. That's a to the negative 8th, but I don't want to leave it that way. I need to convert it. So here's how I think about it. I say, all right, a to the negative 8, that's a fraction. It's a to the negative 8 over 1. And what I'm going to do is I'm going to take that base and its exponent, and I'm going to move it to the other part of the fraction, the denominator. And if I have to move it, that means I have to reverse the sign of the exponent. Hilarious.
Lance McWright, please go to carpool. Lance McWright, please go to carpool. Thank you.
And that's the dangers of filming these at school. So, Lance, I hope you get to carpool. Godspeed, buddy. All right. So when we do that, we got a to the negative 8, and we want to move it to the denominator. And if I have to move it, I've got to change the exponent to the opposite symbol. So it was negative 8. I'm now going to have it as a positive 8 when it's in the denominator. So a to the 8th. 1 over a to the 8th is what that's going to be. It's kind of the shortcut way I like to think about it. Let's do another one. You're going to get good at these by doing just as many of them as you can do. Alright, so let's use blue, number 6. Let's say I've got w to the 5th, x to the negative 4th, divided by y to the 10th, nope, negative 10, sorry, y to the negative 10, and z to the 3rd. Well, there's nothing totally wrong with this, but I just don't like those negative exponents. We got to simplify those. So what I like to do is I take this piece by piece. I'm going to start with this x to the negative 4th, and I need to move him down because leaving the negative exponent, it's just not considered simplified. So let's take a look at what that's going to look like once I move x to the negative 4th to the bottom. We've got w to the 5th over y to the 10th, z. I keep doing that, y to the negative 10th. Z to the 3rd, x to the positive 4th now, because they moved it to the bottom. So I'm almost done, but what I want to do now is I want to take that y to the negative 10th, and I got to move it to the top. I move it to the other part of the fraction, because every time I move it, it reverses the sign of the exponent. And if I move it up there, it'll no longer be a negative 10. It'll become a positive 10. So let's see what that looks like. We've got y to the positive 10 on top now, with w to the 5th, divided by z to the 3rd, x to the 4th. So this is my answer. I don't see anything else in there that I can simplify. I don't see any other common bases or anything like that. So I'm good. That's pretty much it. It's a big answer, but that's all there is. There's nothing else to do. Let's do one more example. And let's make this one a tough one. 16 x to the 4th, y to the 15th, divided by 12 x to the 8th, y to the 7th. Oops, that's supposed to be a 7. Ooh, not good enough. Z to the negative 3rd. Alright, well the first thing I want to do here is I'm going to move this z to the negative 3rd to the top. Before I start worrying about all the other complicated stuff that's in there, I'm going to at least move that to the top so I don't have any negative exponents. So When I do that, I got 16x to the 4th, y to the 15th, z to the 3rd, positive 3 now, over 12x to the 8th, y to the 7th. All right, so there's a lot of stuff going on here. So let's go ahead and start simplifying some things. I've got 16 over 12. Well, that's 4/3. And I'm going to extend this out a little bit because obviously I'm going to have a lot more going on. I got x to the 4th over x to the 8th. Well, x to the 4th over x to the 8th, you subtract the exponents, and that's x to the negative 4th. Every time you do one of these, they go in the numerator. Okay, they go in the numerator. Every time you do a subtraction, it goes in the numerator. So y to the 15th over y to the 7th, okay, that's y to the 8th. And our good friend z to the 3rd over nothing is going to have b z to the 3rd. So now I got to worry about this x to the negative 4th. And I'm almost done. Hopefully you can see the light at the end of the tunnel. But I just want to take this guy and move him down below because I don't like having the negative exponent. So let's go ahead and move him down below and we'll see what it looks like. It's 4y to the 8th, z to the 3rd, with 3x to the now positive 4th because I moved him. That's my answer. Okay, I'm Mr. Bajork, and this was dividing with exponents, and I threw in negative exponents as well. Enjoy.